Hello everyone. In this video I am going to demonstrate 4 to 20 milliamps to 1 to 5 volts current simulator or a current source. So as you can see, this is my setup. So here this is the potentiometer. So I have to adjust this potentiometer in order to control the current from 4 milliamps to 20 milliamps. So this kind of 4 to 20 milliampere current simulator or current source is used in industrial application to control currents in analog input channels. So as you can see here, this potentiometer is responsible to control the current. So as I control the current between 4 and 20 milliamps, the same current will be flowing from this resistor via this resistor to the power supply. So there will be a voltage drop of 1 to 5 volts. This voltage drop of 1 to 5 volts across this resistor corresponds to 4 to 20 milliampere of the current. So this resistor has to be a 250 ohms resistor. I don't have a 250 ohms resistor. That's why I have connected 4 1 kilo ohm resistance in parallel. You can see 4 1 kilo ohm resistances are in parallel. So this is my circuit setup. So I am going to show you the results. So as you can see here, this is the circuit setup. This is the circuit setup. So I am going to control the resistance. So let us control the resistance to 4 milliamps and we will record the voltages. So as you can see here, the current is 4 milliamps, the voltage is 0.98 volts. You can see 0.98 volts. So I am going to increase the current. I am increasing the current. I am turning on this potentiometer. I am turning this potentiometer. I will keep it together. Everything I will keep together. So I am going to increase the current. See, I am increasing the current. So now it is 4 milliamps. As you can see, the voltage is 0.99. So I will increase the current further. Increasing. So at 8 milliamps, I am getting 1.98 volts. At 12 milliamps, I am getting 2.94 volts. At 16 milliamps, I am getting 3.9 volts. And finally at 20 milliamps, I am getting 4.96 volts. So this is how I am controlling the current in the circuit. So let us discuss the circuit. So as you can see here, this is my circuit setup. This is the circuit diagram. So this plus supply of 24 volts DC. This is a 24 volts DC line. This plus supply of 24 volts DC is connected to 250 ohms via 360 ohms to a 10 kilo ohm pot to the ground. So as the current flows in, the 4 to 20 milliampere current will create a voltage drop of 1 to 5 volts DC across this 250 ohms resistor. I don't have 250 ohms, so I have connected 4 1 kilo ohm resistance in parallel. So this voltage drop of 1 to 5 volts corresponds to the current in the circuit. So the same current will flow through all the three devices and finally it will go to the it will be connected to the negative terminal. So this is how the circuit diagram is actually wired. So now you can see here, this is the voltage and current relationship. You can see when current was passing 4.606 milliamps, I was having a voltage of 1.003. 8 milliamps, I was having a voltage of 1.98. I am supposed to have 2 volts, but I got 1.98. 11.93 milliamps, 2.94. 16.01, 3.95. 20.05, 4.94. So this is the reading. So if we keep here, this 250 ohms is exact. If we keep 250 ohms exactly 250 ohms, then these values will be very accurate. It will be here 1 volt, here 2, 3, 4 and 5. So since I don't have a 250 ohms resistance, I just wired 4 1 kilo ohms resistance in parallel. So this is how a current simulator can be wired, and this is a practical circuit, working circuit, and we can utilize it in our daily life. in industrial automation applications. Thanks a lot. Thanks for watching.